Welcome student for the Generative AI and Technique course. In this session we are going to discuss about GAN generator. What's the purpose of using GAN generator means with the help of an GAN generator we can generate a synthetic data set where data may be an text data, image data, voice data and video data. With the help of a generator we can synthetically generate this kind of a data set. For generator we can provide an input as a random noise which is called as an Z, and generator will produce an synthetic data set which is called as a fake data set, which is also called as G of X. Main objective of generator is to produce a synthetic data set based on an input which we are providing. Here random input has been given input for the generator. Random input may be in text, video, voice and image, where this random input is given input towards a generator, and generator will produce an same kind of an synthetic data sets where the samples has been given input towards a discriminator. Meanwhile, discriminator also get an input from a real image data set, and discriminator will classify the given data as a real data or else a synthetic data. If discriminator is unable to produce an output as a synthetic data or else a real data means, then those data will be back propagated towards a generator until we receive an 100% accuracy. These are the phases associated with a generator. The first phase is an input phase. Over an input phase we can provide a random noise as an input towards a generator. Then next phase is a future selection phase. Over in future selection phase, futures has been extracted. After extracting the futures, then we need to provide those futures towards a training module. Then image generation phase is a third phase which contain n number of parts which will be discussed in an upcoming slides. The next phase is an evaluation phase. Over an evaluation phase, over a discriminator will classify whether the given data is a fake data or else a real data. If discriminator is unable to classify the given data as a fake data or else a real data means, then the same data has been back propagated towards an generator until we receive an 100% accuracy. These are the phases associated with the GAN architecture. The first phase is a latency phase. Over this phase, a random noise has been given input towards a dense layer. Over a dense layer, future selection has been completed. Once future selection has been completed in this dense layer means, then over a batch normalization phase, training has been completed. In this phase, data training has been completed. Once data training has been completed means, then we need to give the image towards a reshape layer. In this phase, image has been reshaped. Then reshaped image has been given input towards a transport convolution block. Over this transposition convolution block, image has been enhanced or else and downsized based on a user prompt. Here image size has been enhanced based on a user prompt. Once image size has been enhanced means, then we need to provide that enhanced image towards an output layer. Output layer will receive a final output like this as a fake image. This is another method of representing an GAN generator which contain a collaborative diagrammatical approach. Here random noise has been given input towards a generator, and generator will generate a fake image which has been represented as a G of X, where this fake image has been given input towards an discriminator. If discriminator is able to classify the fake image as an fake image or else an real image as an real image means, then no problem. If discriminator is unable to classify the given image as an fake or else an real means, then the same set of image will be sent back towards an generator until we receive an 100% accuracy. Where these are the advantage of an GAN generator. With the help of an GAN generator, we can simulate a synthetic data set where those kind of data set will helpful for an developing an GPT based models. With the help of a GAN generator, we can increase the image size towards based on an user prompt. If we provide an low quality image size means, with the help of an GAN generator, we can obtain a high quality image as an output. These are the industrial application where we can apply the GAN model. One is in healthcare, next one is in arts and creative for creating an image, next one is in machine learning model, and also scientific research side also we can use this model to generate a synthetic data set. With the help of an GAN generator, we can synthetically generate an data where those data can be used for an testing purpose. Thank you. We can discuss the next topic in the next session.